Hello, my name is Jacob Fefer, and this is my micro-teaching lesson presentation. The topic is physics, specifically looking at momentum, and the grade level for this lesson is 12th grade. The content standard for this is HS-PS2-2. Use mathematical representations to support the claim that the total momentum of a system of objects is conserved when there is no net force on the system. The objectives for this lesson are the cognitive objectives, which are students will be able to describe the difference between elastic and inelastic collisions, and that students will be able to apply the concept of momentum to a system and use momentum to calculate the energy in a system. The psychomotor objective is that students will be able to design an experiment that proves energy is conserved in elastic collisions, but not all inelastic collisions. And with that, let's get started. All right, class. So far we've talked about momentum, which is just P equals mv. What units were P in? Right, a Newton second. All right, a Newton second. So momentum is mv, where m is mass, and v is velocity, which are in units of kilograms and meters per second. And so far, we've looked at collisions where two things come together and then they bounce off. Right? So this is 1 and 2, this is 1 and 2. So things come together and then immediately bouncing off. Right? Is this what every sort of collision ends up in? No, we have, like, if something is on some train tracks, okay, and a train comes by, pretty poor train, but you get the gist. If a train comes by and smashes into, like, let's say a cart full of coconuts, okay, the train will ram into it, and the coconut cart will essentially be attached to the front of it, right? Coconuts will fly everywhere. Okay, but the cart will be right in front of the train. Okay, so not all collisions end up with the two objects bouncing off. Okay. And that's a fundamental difference. Okay, so we really have two types of collisions, right? We have the ones where they bounce off, and the ones where they stick together. Okay, the ones where they bounce off, this is called elastic. Okay, and the ones where they're still connected are called inelastic. All right. Let's do a practice problem. Okay. So let's do a problem with the carts, since we'll be using the carts this afternoon. Okay. So if we have a cart, and the carts have little magnets on the front. Okay, so let's say we haven't added any weights to the cart, so it's just a kilogram. And let's say it's traveling at 3 meters per second. Or even 2. Make it a little bit easier. 2 meters per second. Okay, which is pretty quick. And let's say we just have another cart with a corresponding magnet. So it'll stick. Okay, that's at rest. So it's still 1 kilogram, but it's at 0 meters per second. Okay. Since we have the magnets, they'll stick together, right? And now, okay, well, now we don't have two objects, now we only have one object. But we still need mv, right? Because we got to look at the change in momentum. Well, what is m? Well, how many carts do we have? 2 carts. What's the mass of each cart? 1 kilogram each, right? Well, they're together. Yeah, so the mass is 2 kilograms now. Okay. Velocity. Okay, we now essentially only have one object, right? Yeah, because they'll be, if they're stuck together, by definition, they're traveling at the same velocity. So what I want you guys to do, I'll give you a minute or so to go through it and work this out. Okay, it's been a minute. Who has an answer? 1 meter per second. Okay, let's see if you're right. So we'll have PV and PV. Okay, sorry, MV and MV. So we have 1 kilogram times 2 meters per second plus 0, right? Okay. The velocity is 0, so we have no momentum. Okay. Now let's look at our after, because our beginning still has to equal our after. Conservation momentum still applies. So we have 2 kilograms, because it's 2 carts put together, and we have V final. Okay. So this is just 2 Newton meters, right? Okay. And if we divide both sides by 2 kilograms, okay, we'll get V final is equal to 1 meters per second. So you're exactly right. So what I want you guys to do is I want you guys to use the collision carts, and I want you guys to explore what happens in elastic and inelastic collisions. So doing some mathematics, getting the weights, the masses, sorry, not the weights, getting the masses, getting the velocities, and calculating out your delta P's. Okay. Now, what I also want you guys to look at is, could you figure out the energy? Yeah, I mean, it's just 1/2 mv squared. Okay, we'll worry about potential later, but for right now, it's just 1/2 mv squared. And I want you guys to look at energy and see what happens in the energy of the system. Okay, you guys will be assessed on this, okay, based on your results in your labs. So show your work, and then we're also going to be having a quiz later on this week about elastic and inelastic collisions. So make sure you guys are ready for that. All right, get to exploring with the carts.